just tuned in, we are watching AU Talks, and AU Talks is brought to you by the Association of African Universities, and we have been hosting these pretty young ladies from Methodist Girls Senior High School. We've already done the discussion on STEM, and now we're moving into the podcast session of the robotics. And I have with me Vanessa. Vanessa will tell us how robotics came to Ghana, a bit of the history, and after that we'll go straight to explain what we have here, and so that we would enjoy ourselves and then learn one or two things as well. So Vanessa, the floor is yours.
So robotics is one of the aspects under STEM, that is science, technology, engineering, and mathematics. And it involves the building and programming of robots to perform specific tasks.
Okay.
But these ones are miniature robots.
Okay.
So we look at the architecture of these and we build them in real life to perform such tasks.
Okay.
And we use the Lego kits, which we put together. So as you see this, it wasn't structured this way. We built it ourselves to perform the specific task.
Okay.
And we also use the Lego Mindstorm EV3 language to program for it.
Okay.
Everything has its language. So that's the language the robot understands.
Okay.
And
so does it mean that everybody here can build the robot?
Yes.
So if I dismantle it, you can put it together?
Yes.
Should I dismantle it now?
Choose
You should choose any. Okay, for the sake of our time, I won't dismantle it now. Okay, so where do we start from?
I'm not done.
Done. Okay, fair.
And robotics was introduced in Ghana by Dr. Chebi Olenu. He's a Ghanaian-born engineer working for NASA's Jet Propulsion Laboratory in California.
Okay.
And when he introduced it, it was handed over to GRAF, that's Ghana Robotics Academy Foundation.
Okay.
So they oversee all the activities of robotics and STEM in Ghana.
Okay.
Yeah.
All right.
So basically, that's what robotics is all about.
Pretty good, and I'm so much interested that these things were built by yourselves, and then if I dismantle it, you will be able to fix it. That's cool.
Yes.
So let's start from here. You tell us what we have here, and then from here move to the next table, and then the last one. So tell us what we have here, and what should we expect?
Okay, this is bottle sumo, and sumo in itself is an art. It's an ancient art of wrestling in the Japanese culture, whereby two, should I say overweight men try to push themselves off of a board or a ring to win themselves titles and monies. And people also found this as a source of entertainment because it was fun seeing two men fight, and it was also fun betting on who's going to win. It's like a football game, but more of more aggressive and more violent. Okay,
so you translated that into robot for us too. So it's a sort of entertainment, right?
Yes.
Great. All right, but I don't see any bottle. Oh, that's it. All right. Yes. Okay. I bet you want to add something.
Yeah. So this year's sax bottle sumo was added to it, and in bottle sumo, two robots are placed on a board, and the bottle is placed in the middle, equidistant from the two robots. Okay. So the robots are supposed to push the bottle off the board, and then fight each other. When a robot goes off the board, it's called sumo side, and the one which stays on the board for 3 seconds is declared as the winner.
Okay. We'll give the robots an award, right? Interesting.
And
all right.
When it comes to its
Sandra?
practicality, this was mainly coined because we can't have robots or build and program robots that can defend our country in times of need, when we have to fight other maybe harmful things that are supposed to be a hindrance to our country. So, and also it's a form of entertainment. We won't like to see people getting hurt over the fact that they are supposed to wrestle each other just for titles and money. So we can use these robots as a source of entertainment also, because it's quite fun watching them move on the field. Yes.
Okay, I think the young boys will be very much interested in this one. Great. All right. So do we start?
Yes, we'll actually So before you start, the judge is to hold the bottle, and when he is to count to 3 before you start your robots, and they are supposed to be opponent robots, as in from different teams. Yes, and when they start the robots, the judge is supposed to place the 2-liter bottle, which is 1 liter filled with water.
Water, okay.
Equidistant from each robot, yes, on any side of it. So
okay.
Before they start, I'm supposed to count to 3, and then they start the round.
So you can place it there yourself if you want to.
Okay.
But it should be
all right.
So I count to 3.
You said equidistant, but in any angle, right?
Yes.
Okay. So to be
I
very...
have to count to 3 first.
Okay.
So 1, 2, 3.
Let me put it here.
Well, the reason why you're not moving it was they had to wait for 5 seconds
Before it
actually,
moves.
yes.
Okay.
So that's the part where they are fighting each other. So with this sumo side, when the other the opponent robot is pushed off the field.
2, 1.
So after 3 seconds, when this is still on the field, it wins the game.
Okay.
Yes. Stop it.
All right. So can I change the direction of the bottle?
Yes, you can.
Maybe let me put it in the middle. Yeah.
Put it there. Now better.
Trying to say input.
Yeah. So for the judge, you can place it anywhere on
the ball.
any edge of
Sandra,
the field.
it's not equidistant. It's too close to
It's not.
Still get your bottle back.
Okay.
So 1, 2, 3.
Okay. Let me put it here. This one must be a bully. Oh.
And it's pushed off. Stop. 2, 1. So stop it. That's after 3 seconds.
But don't you think he was struggling to come back to the board?
Yes. Because
it part
it's
of it?
actually supposed to be raised a bit.
Okay.
So when it falls, you know the effect of the fall. So it can't come back to the board.
Okay. So it's just about which one has the strength to push the other on the board.
Yes.
And it wins.
Yes.
All right. Amazing. Great. Anything for us to know about this before we move to the next one?
Oh, it's basically what we
Yeah,
explained.
I think it's interesting. More or less like wrestling for us. Okay. All right. Let's move to the second board. What will we be doing here?
Well, for this competition, this is the main competition, and this year's competition is about binary blocks.
Okay.
Yes, for this competition, it's about we having a target number, and our mission is to find its binary, program and build a robot to arrange black and white boxes according to that binary given. And knowing that binary deals with the numeric system of 0 and 1, in this game or competition, the 0 represents the black and the 1 represents the white. For this competition in the national qualifications, you have to go through the pre-competition, which is RISE 2018, which we are the first girls' school to win the competition within
in Ghana?
Yes, in 2 minutes.
Okay.
And we are the first school to qualify for the national competition, which we place first and second with 2 teams, and that's how we are qualified to represent Ghana for this competition.
Okay.
Yes.
Where exactly?
In Michigan, U.S., Lawrence Technological University.
Great.
Yes. So binary also shows how it is applicable to our lives. For example, in programming hardware operators and logic operators and stuff with our PCs, mobile phones, and even looking at the power buttons on these devices, we have the 0 and 1 symbol on it, where the 0 represents the off or false button and the 1 represents true or on, so you can. And also it also helps in communication with the computer and the computer user. So whatever information you give it to the computer, it takes in that that information, processes it with the code of 0 and 1, and gives it back to the user with the programming that the user understands, maybe in alphabets or numbers.
Okay.
Yes. So and the competition day, we will be given the judge or the supervisor will be given will pick a number at random from 0 to 15.
So will I be picking a number here?
Yes.
Okay.
From 0 to 15, and we will have to arrange the. We will have to find the binary of that number. They'll give us a 30 minutes time to work with that, and on that day too, before the robot, after the robot is quarantined, that's where they'll place 2 boxes on the game field.
Okay.
Before, and
that one we will not have to know unless it is time for the game before you actually get. So you have to be prepared for anything. Because you don't know what is going to happen, you don't know which number is going to be given, and you do not know the color of the box given. So I'm going to ask you to choose a number, yes, a number from 0 to 15 so that we can find its binary.
0 to 15?
Yes.
I don't know which one to choose. But let me go for 6.
Okay, using 6. So we're going to use the calculation using base 2, which is 0, 1, 1, 0. Okay, so now to make things more interesting, I'm going to ask you to choose the color of the boxes that are going to be placed.
Okay.
So for B1, what color do you want over there?
Maybe a black one.
Okay. Right. And for B2?
Maybe we pick another black and see if that will work.
No. Let's just see.
Yeah, let's start with a black. Yeah.
Okay, so.
Must it be linear or something?
No. For this competition, for B1, it has its minimum value of 35 centimeters away from the black line, and its maximum value is 50. So the judge can actually place the box within that range. And for B2, its minimum value is 35, and its maximum is 90. So within that range, the judge can place the robots at any distance of their choice. So you just have to make sure that your robot is prepared for anything. Anything.
Okay.
Yes.
Let me stand by and relax
and
enjoy.
Right.
So that is a 6.
Sir?
Okay. That is a 6, right?
Yes, and also on the competition day, we are allowed to have cheat sheets.
Okay.
That will help you choose or select your programming according to any binary given or any number of the box on the board.
Okay.
Yes.
I hope I didn't choose a difficult one.
Sorry?
I didn't choose a difficult one.
Oh, no.
It's okay.
Yes, we are prepared for all.
Oh.
So there's nothing that's difficult, there's nothing that's easy. Okay.
Super.
Wow. Right. So for this competition also, we have another game in the game, which is a game ending mission. So it also shows like, it's somehow like a proof that you know what you're about, you know what you're doing, and you are the ones who worked with the robot. So they can give you a game end mission that at the end of the run, either the robot should come and face the black line on the start zone, should face east, northwest, or south of it. Yes. And you have marks for each slot. So for each slot, for the robot to be perfectly within the slot without it touching the black line, you have 15 marks each.
Okay.
Yes, and that slot is our most significant bit, slot 4, 3, 2, and 1, and this is our least significant bit. Okay. So whatever color, whatever binary given, whatever color that has to be there, you have to stack. Okay. Yes, and for this, how do I say, technique or design we use is that Lego can't lift. Okay. With this weight of the box, it can't lift. So we decided that we'll use a technique or a strategy or a design to rather slide it to make it easier. Which is what we have displayed over there. And also for the marks given in our game end mission, we have 13 marks. And during the competition, your robot is supposed to stay intact throughout the run, and then you get marks for it. And if any part of the robot falls off the robot and drops, that's the end of your game. That is qualified? Yes, that's the end of your game. Like, game finished, like, it's finished. Game over. So you should make sure that your robot is actually firm, strong, that whatever happens, not a single piece falls out. Great. And you should not touch your robot. Your robot should be autonomous. That is what it's all about. So we are here looking at the light sensors. The light sensors helps us navigate throughout the board. So knowing that we have two colors, black and white. And as they said, the white equal to MS plus C helps us standardize our light sensor reading. So our light sensors also helps us navigate through the edges. Sure. So on the competition day, we're going to have the board, but then on the floor, it's going to be a darker surface. Okay. Yes, that would take the region of the black value. So then the light sensors are supposed to help us know the difference between, to help us know the error. So if, for example, let's say we are to put a white surface, how do I say, on the ground, and also we are also running on a white surface. It won't move, but it will have to correct, because looking at the skeletal form of that mind block, we're using that. We have the light reading of this light. So knowing that we're using with light sensor 1 and 4, we have the reading of light sensor 1 is what we are using, and then we subtract it by the neutral reading, which is 50, and that will give us your error. Okay. So if you are given the movement on the blackboard and you have a white surface there, the robot will move, but will try to find a darker area for you, for it to balance itself and correct its error. So that's error given. So you are given that your light sensor reading minus that neutral reading of it, so that you can be able to get this thing. So it's also mostly just about your calculations and everything. Yes. Charlie, you can do it once again for that is very fantastic. But I have a very simple question. In terms of everyday life, okay, how can we translate this into everyday life? Our everyday life. So for binary can also help in our shipping industry. Okay, good. Yes, we don't know what's gonna be in the future. But what I'm saying is that for the shipping industry, we're gonna have huge things coming. We're gonna have shipments, we're gonna have so many things. So instead of us having human beings, you know, struggling and sweating, we can just build machines and robots. Lifting up our cocos and everything? Yes, and arranging them according to that binary or to that color or weight or anything. That's without using a human to supervise. Just all you have to do is just program, and that's all. And also to be kind of have a robot. What about our construction industry, building of houses and? Yes, that one too. We can have, just put on the designing. It's only based about knowing what you have to do and programming. Programming, okay. Yes, because the robot doesn't know what it's doing. It's all about you programming. And we also have a robot that sorts out colors. So it's a color sorting robot. Okay. So you can put multiples and multiples of colors. Just put its container there. All you have to do is program the robot. Okay. So garbage in, garbage out. Yes. You are able to program it well. Yes. So you can even help in agriculture. Put your containers out there. Put your mangoes, oranges, watermelons and stuff. Just put it in there. Instead of using a human being to pick out and waste time, you can just use the robot to just sort it out, back and forth, and then before you know, everything goes fast. And people will be able to get food. Food will not get rotten easily. like that.
We want a robot that can weed our farms for us.
Yes,
also. That is also possible.
Yes, it's possible if we actually work hard to it.
Okay.
Yes.
Okay. All right. But then tell us, this is the only thing that you are presenting during the competition.
Yes.
In Michigan?
Yes. This is actually the main game.
Competition. Okay.
Yes. And for Ghana, we're going with 2 teams. We have acrobats and iBot.
Okay.
We're going with 2 teams, and also for bottle sumo, we're going with acrobats and iBot, since we are the main 2 teams representing Ghana. Yes.
All right, congratulations.
Thank you.
We hope that you win at the global space also, and then you make Ghana proud. Let's go to the last one. This is about. Okay, tell us what we are going to learn from here.
This is about smart cities.
Smart city.
Yes.
Okay.
Smart cities. In this game, we are going to use nodes instead of satellite poles.
Okay.
So this is for a competition in November in Hungary, in Europe. Yes.
And
so we are just going to, not me, 2 team members are here.
Okay.
We're just going to show you a piece of the programming and how everything works.
Well,
It's supposed to pick up a node from here. So you see it's going to lower, raise it up, and then place it there. And we see the cables connecting it.
So this is basically for construction?
For planning our cities. So in the near future, we won't be using satellite poles and everything, since the nodes are more efficient. Yes, so that's what we'll be using for our electricity.
Okay. Any addition? Anything else?
Yeah, as you are placing the devices in the white areas, should be in the correct orientation.
Okay.
As you can see here, there are numbers 1, 2, 3, 4, and identifier blocks will be placed over there of colors red, blue, yellow, and green. So at the competition, they will arrange the identifier blocks for you, how it's going to be like. So for instance, if we are at the game and they give us one to be blue, blue corresponds to east. So when we take the node device from this area, we have to place the node device in the east
region.
Yeah. So the node must face the east side.
Okay.
In the white area.
Okay.
As in all the colors, according to how they give us. And you have to also establish an optical network between them. There will be optic cables placed over here. And you have to pick the optic cables and place them in the orange area. Over here. So that it will be like a smart network. We are connecting the node devices together.
Okay. So this is in US and this is in Hungary. What about this one? Also in US.
Yes, but for this one too, it's also in Denmark.
In Denmark?
Yes.
And your school is represented?
Yes.
Oh, I wish
And we have other competitions as well. First Global in Dubai, and 2 students are representing.
From your school?
Yes, alongside Wesley Girls
High School. Is it the Cape Coast or Kumasi one?
Cape Coast.
Okay.
And we have one also in UNESCO, and one named UNESCO in Ireland, yes, and one Maryland, and one student is representing, yes, our school. No, Ghana, but from our school.
From your school?
Yes.
Yeah, your school must be proud of yourself. Okay, but then let's talk about funding. Who is funding all these trips? Is it a school? Do you have funders? Do you have institutions that are supporting you? Or are you looking for more sponsors? What are you looking up to?
Right now, for the funding of the trip, our parents are funding, but they can't fund for everything. Whatever they give cannot cover the entire trip. So we are pleading to the NGOs, governments, individuals out there to help us fund for this trip so that we can be able to represent Ghana throughout this competition and raise Ghana up, because winning this competition doesn't mean for us to get the trophies and medals and put it in our school's cabinet, but it enables us to get a name for Ghana and also raise Ghana high. So we're just pleading for them to help us in whatever means they can,
just to help us and fund for the show, because we don't only have these competitions, we have other competitions to go to give us the opportunities to show what Ghana is about, what we can do, and the sources we have. We're not just Ghana for Ghana's sake, but we already know that we have, you know, specific or unique sources within us that we want to exhibit.
Okay. So if I tell you to mention 3 organizations that you want support from, which are the 3 organizations you mentioned?
I would say we want from Delta.
Delta?
Yes, Delta Emirates and...
so that is for the airlines?
Yes, yes. Also one from the Bank of Ghana.
No, feel very confident.
Who else you want from?
Who knows, maybe the president of Ghana will sponsor this one?
No, William.
Okay.
All right. And the president himself.
Himself.
You should actually see what we're doing. Like we are working hard in everything we have to do. So they should actually look on the bright side, look on what we're gonna achieve when we get this opportunity. Because once we gain the glory, they will also want to experience the fun in the glory. So it's better to actually place an input in it so that when the glory comes in, we all get to rejoice in it.
Amazing stuff. Congratulations to your school for winning some of these slots to represent Ghana. And like they said, they are just placing a special call to all the institutions in Ghana, the president of Ghana, and the key institutions. Please come and support us, and let's make sure that we are able to project our country higher and higher and higher. But one key thing to me is the fact that we need to translate these things into everyday life. Yes. I'm so much interested in this and that as well. How we'll be able to maybe identify a problem in any of the sectors of the economy, especially when you go to the revenue collection. You know, the toll booth. Yeah. There are human beings in there. Yes. We believe that we should be able to use some of these technology to advance the things that we do. So you've done well. It's so much brilliant and innovative. But I'm looking forward to the next session where you will be able to translate these things into real life and solve societal problems. So on this note, may I thank all of you. But before I do sign you off, maybe you have your final words you want to say to your teachers. But let me bring the teachers on board so that everybody knows them as well. Can we have the 2 wonderful teachers who came with them? Oh, clap for them. And then they also have to share with us how has the journey been. I'm sure when you started in the school, it was something. Oh no, please come closer. When you started in the school, the concept wasn't too familiar with, or they were not too conversant with it. How did you break through all the processes, and how have you been able to achieve this greater height?
It's been quite a lot of challenge, especially in an environment where these things are not understood.
Sure.
In the curriculum, we don't find it. So it is obvious that even a teacher can tell a student you are wasting your time, and it happens all the time. So it's a challenge, but I thank the students, I thank their parents, and for their support. They've been very tremendous in making this thing a success. Okay. The other challenge has to do with funding. To build one small robot like this, you need a kit that costs not less than $500. Oh. So to go to a competition with about 5 robots, that's about 5 kits. And because it's a club, we have about 50, we have more students in the club. Everybody needs to get the knowledge. So you need more kits, you need more equipment. So finance is a challenge. Okay. It's a major challenge. So these are the main challenges we have.
Okay. All right. And did you add anything to it?
Yes, I would like to say thank you so much for having us, AAU. We are very grateful. And we are very grateful to our students as well. The commitment, the discipline, we are very grateful.
Okay,
thank
all
you.
right. And also, we have 2 strong institutions that are backing you. I know they have good packages for you. I don't know if I can call the Ford Foundation and then the NEC to just also give us a few words. Let's clap for Ford Foundation. Maybe Ford Foundation would, and the Ford Foundation alumni would at some point provide some support. Angie, are you providing any support? We want our girls to go higher. What can you do as an alumni institution?
You know, we are into champion social justice.
Sure.
And we believe in STEM and the fact that these girls are coming up to be our future scientists, talking about the doctors and the engineers a lot of the ladies are not in that field. So we are very particular about ensuring that they move to that higher height.
Okay.
So what we can do is to continue, you know, to talk to people and also crave on the indulgence, especially of the president, as the lady said, to come to their aid, to support them. Because it's all about the country. It's all about the country. And we believe in brain gain rather than brain drain. And so they should support them to go out there and come back to build a strong economy for our country.
Thank you so much. And then on this note, may I thank everyone for coming. And then also we wish that we'll have another platform where you would share your knowledge. On the show, you were mentioning research. Please don't keep your research output in your school alone. I'll come after you, and then together we'll see how best we'll be able to translate these things into commercial terms to promote our continent as well. Thank you for watching AAU Talks. My name has always been Kwesi Sam, and today we have been hosting wonderful young ladies who are into STEM, and STEM is science, technology, engineering, mathematics, and then they also are in the robotic club of their school. They get to share with us what they've been doing and then also the upcoming competitions that they have. Support them with any resources, any institution, anything at all that you think would promote their work in their schools and then on the continent and then at a global level as well. Please support us. If you have any support or donation, just come to the Association of African Universities or to Methodist Girls Senior High School, and that will be sorted out. My name has always been Kwesi Sam. Thanks for watching, and thank you to my crew as well.